Are we?
Yeah.
Yes.
So, on Friday or Thursday? On Thursday, we talked about Chebyshev's and the empirical rule. Today, we're going to talk about z-scores and percentiles. Sorry, I don't know why it makes me do this again every time. Okay, so we're going to calculate and interpret z-scores, and then percentiles go along with that for any observation in a given data set. So first thing that we should talk about is what is a z-score. Don't copy down all of this. Copy down what's most important. A z-score tells you how many standard deviations an observation is away from the mean. A negative z-score means that the observation is below the mean. Positive z-score means that the observation is above the mean. So z-score is how many standard deviations away from the mean you are. It is used to convert a value with units into a standardized value that does not have units. So z-scores are really used to compare observations from different data sets. Data sets that have different means and different standard deviations. So if you scored a 70%, let's say, on the Chapter 3 test, and you went and you talked to somebody in 8th period, and that person scored a 70%, how do we know who did better relative to the class? We don't, because each class has a different mean and different standard deviation. So that's when a z-score is used. Okay, so you should probably know the formula. Here's the formula for a z-score. You get z equals whatever your observation is, subtract the mean, divide by the standard deviation. This should be logical. I'm taking where I'm at, subtracting the mean, that tells me how far away I am, dividing by the standard deviation, which will tell me how many standard deviations away I am.
What's the amount of that?
Standard deviation.
Okay.
So that's a sigma. So let's do an example. This would be a case where you might use a z-score. Which day was more extreme? So based on this data, it tells us in October of 2008, for the marathon, it was 84 degrees. October for 2007, it was 88 degrees. So logically, 88 degrees is higher, but is that more extreme relative to the average for that time of year? So what we're going to do is we're going to calculate a z-score for both days. So for 2008, here's what I expect to see. I expect to see first a formula. Okay, so the actual temperature in 2008 was 84 degrees. Then I'm going to subtract the average, which is 64, and divide by the standard deviation, which is 10. So I get a positive 2. Okay, so conceptually what that means to us is on that day, the temperature was 2 standard deviations above the mean, above what would have been expected. So then we got to look at 2007, calculate a z-score again. I already wrote down the formula, so I'm not going to write it down again. But we're going to do the 88 degrees, subtract 66, which is the mean, divide by the standard deviation, which is 10.2. You get 2.16. So this day in 2007 was 2.16 standard deviations above the mean, above what would have been expected. So which day was more extreme?
October 7th.
October 7th. Okay, if you are looking at your test score, your Chapter 3 test score, do you want a positive z-score or a negative z-score?
Positive.
Positive, right? It means you did better than the average. If you're looking at the amount of time that it takes you to complete a homework assignment, do you want a positive standard deviation or a negative one?
Negative.
Negative, right? It takes you less time. You're below the mean. Okay, that's z-scores. Not too bad? No? Okay, now we got to talk about percentiles. Percentiles, you've heard for the ACT, you're at the 98th percentile or something like that. If you're at the rth percentile, that means R% of the observations are at or below your value. So if you're at the 90th percentile, 90% of people scored where you did or below. Nice thing about percentiles is they report relative position for any distribution. Doesn't matter the shape. So the empirical rule is only for normal distributions. Percentiles are for any distribution. Okay, let's do an example. So this is the distribution that you have. I think it's looking at expenditures. So here's what we're told. We have 50 observations. Here's how to read this stem and leaf plot. This part right here is the stem. Everything to the right is the leaf. You guys know what this stuff to the left is?
I'm gonna guess it's percentile. Or
No,
like
book a guess.
a cumulative or like percentile, I guess.
No, book a guess. You don't know this, so unless you saw the pattern, you.
Oh. I was gonna say cumulative, like observations.
Yeah, kind of. It counts the number of observations. So at the end of this row, there's 6 and below. At the end of that row, there's 22 observations and below. You know what the parentheses means?
Around. Is that starting over?
That's the middle. So that I'm going down. So it's meant to help you, but maybe it doesn't. I don't know. I think every year it confuses students. So anyway, this is what we're finding. We're going to find the 10th percentile, the 50th percentile, and then observation 21, we're going to find what percentile that is. So to find the 10th percentile. We're going to take our 50 observations, multiply by 10%, so 0.1. So I get 5. That means that my 5th observation is the 10th percentile. So if I look, my 5th observation is 1, 2, 3, 4, 5, 7. So the 10th percentile is at 7. '50th percentile. I'm going to take my 50 observations, multiply it by 0.5, so I get 25. So 25 is my 50th percentile. Through this row is 22 observations. So then I have 23, 24, 25. So that's 13. 13 is my 50th percentile. What's the other word for 50th percentile? The median. Yeah, the 50th percentile is the median. Ben?
So then couldn't the median and the 50th percentile be different numbers?
Yes, theoretically.
Then, but you can still use them interchangeably.
And then lastly, the value 21 represents what percentile? So that number right there. What percentile is that? So the first thing we got to figure out is what observation is that. Don't count from the beginning. Let's be smart. Count from the end. So this is 50, 49, 48, 47, 46, 45. That's the 45th observation. So I'm going to take 45, divide by my 50 observations, and tell you that 21 is the 90th percentile. Questions? Can we keep going? Yeah? Okay. We're going to go back to those temperatures in October. If October the 5th, the high temperature, oh my gosh, sorry, my grammar's not that good. If October 5th high temperatures are approximately normally distributed with a mean of 66 and a standard deviation of 10.2, find the approximate percentile for a high temperature of 88 degrees. Okay, they told us one thing that's really, really important, is that our high temperatures are approximately normal. Why did they tell us that? So that we could use the empirical rule. I told you, anytime they use the empirical rule, what do you have to do?
There has to be the word normal.
Yes, that's when to use it.
That's approximately.
Yes. What do I require in your work? Yeah, the diagram. So 0 is our mean. And then I have 1 standard deviation, 2, 3, -1, -2, -3. It says our mean is actually 66, standard deviation of 10.2. Kind of ran out of room, but I just added 1 standard deviation, subtracted 1. Okay, high temperature at 88 is about here. Okay, so percentile means everything below it. So I need to find all of this right here. Now that 88 degrees is really, really close to 86.4. So with the empirical rule, you can't say anything between 2 and 3 standard deviations. We know 2 standard deviations, we know 3. We don't know in between. So because 88 is really close to 86.4, we're going to find the percentile for 86.4. 86.4 is 2 standard deviations away. What percent of the data falls within 2 standard deviations? 95. Which means 5% falls outside of that. So then this tail is 2.5%. And then this tail is 2.5%. So everything is included in this percentile except for that tail, that 2.5%. So we would say that our 88 degrees Fahrenheit is approximately the 97.5th percentile. I took 100 and I subtracted that 2.5%. Now, in reality, is the percentile a little bit higher, a little bit lower than that? A little bit higher, right? That's the percentile for 86.4. So if we go to 88, it's going to be a little bit higher than that. But that's the best that we can do right now. Questions? You guys ready to do one? Can I erase this? Okay, I would like you to find all these percentiles. So, a z-score of -3 is 3 standard deviations below the mean. A z-score of -2 is 2 standard deviations below the mean. Complete this table for a distribution that's normal. So in other words, use what? Empirical rule. So right now, take 2 minutes. Do this with the person next to you. So like maybe move your desk together.
zero to 50, right?
Negative 3 on the end of the tail.
And then would you go from, is it like negative 2 to negative 1 to all the way up, or like this way? This way.
On the very
So I did to the left.
Yeah.
If I do negative 1, it is
So can you correct me then?
Oh, so it would be
Negative 2 is the These are 178. What? 170?
if 60.
Okay, moment of honesty. Do we have any idea what we're doing? Would it be helpful if I started us out?
Yeah.
Yes? Okay, Ben, if you don't want to, just don't listen, okay? Okay, you should have drawn yourself a normal curve. I have 0, 1, 2, 3, negative 1, negative 2, negative 3. Then draw your percentages. So in here, this is 68%. This is 95%.
66.
No, definitely 68. And then within 3 is 99.7. Okay, so if I'm looking for the z-score for negative 3, that's the percentage of the data that's at negative 3 and below. Now, 99.7 is between negative 3 and positive 3, which means 0.3% is outside, which tells you that this tail is 0.15%. This tail, likewise, is 0.15%. So for a z-score of negative 3, the percentile is the 0.15th percentile. For negative 2, if we do negative 2 and everything below it, 95% is between negative 2 and positive 2, which means 5% is outside. Divide that in half, and you get 2.5%. So a z-score of negative 2 means you're at the 2.5th percentile. Does that give you enough information to keep going?
Yes.
Okay, take 1 minute and see if you can finish this, please.
Sorry, what?
30.
0. That's the 50th. Oh, that's
Yeah, kind of.
30.
I think 1.
36.
See, they were like this. So 68% has to be negative 1
Yeah, sure.
That means 32 has to be on to the other side. Right?
84.
But yeah, it's
Drawing.
16 divided by 2 is 34.
No, you don't divide by 50. So 68 happens between 1 and negative 1, right? You want to know how many is from negative 1 to 3? Or negative 3?
Counted for.
And then.
Are you asking a question or stating something?
I'm trying to say. So if it's like.
Oh, you're talking
the score is
stating.
negative 3, then you're trying to find like what percent of the observations are like
but then you have to add.
On the function above of like the graph.
Because that's the next one would be the x is 2 is 34 plus 16.
Yeah, that's 84 points. Yeah, for the first.
86 for 2, 86 plus 2.
For what? Two?
For 2, or 57.
No, so 95% happens between -2 and 2.
Right, I got it. Okay, subtract 2.5.
This is what you should have gotten.
2.35.
Which ones would we like explained?
1.85, yeah.
We got all of these right. That would shock me.
I did.
So we don't want to talk through any of them.
Wait, one, like the z-score of 1, 2, and 3.
One. 1, 2, and 3. Okay, how about let's do 2. Yeah, let's do 2. Okay, so z-score of 2 is 2, and then all of that stuff, everything below it. Anytime that you get above 0, what I like to do is I like to instead find that stuff that I'm not interested in instead. Because what some people do is they find like between 1 and 2 and 0 and 1 and -1 and they add it all up, and that's too much work for me. So instead I say between -2 and 2 is 95%, which means outside of those two is 5%. So I divide it in half. So this is 2.5% here. And then same thing with that tail, 2.5%. I don't care about that one on the left. So I take 100 and I subtract that 2.5% because it's not within like what I'm interested in. Does that make sense? Questions, comments? Okay, we're gonna do 2 more examples that directly relate to the homework that you guys have tonight. So please pay attention to these. Okay, this one. In a study investigating the effect of car speed on accident severity, 5,000 reports of fatal automobile accidents were examined, and the vehicle speed at impact was recorded for each one. It was determined that the average speed was 42 miles an hour, and that the standard deviation was 15 miles per hour. A. Roughly what proportion of vehicle speeds were between 12 and 72 miles an hour? Ideas?
So since your standard deviation was 15, 30, or times 2 is 30, so then that means 2 deviations lower, 2 deviations higher from the mean.
Okay, can I just stop you right there?
Yeah.
Okay, so first thing is he figured out how many standard deviations away are we talking. So if the mean is 42, I'm going to do this in z-scores. So if I take that 72 and I subtract the mean of 42 and then I divide by my standard deviation of 15, I get 2. That that positive 12 is going to correspond to a standard deviation of -2. So the first thing he said is we're talking about 2 standard deviations away. Okay, Ben, did you have a direction after that?
Yeah, are you allowed to use empirical rule for this one?
Okay, so that's really important. Can we use empirical rule?
No.
Why not?
It never said it was normal.
Net didn't say normal. We can't assume. So what do we have to use? Chebchevs, right? Not Chebyshevs or Chubbyshevs or Chebchevs. Okay, so Chebchev's rule is this one, the 100 times 1 minus 1 over k squared. What's our k in this case?
The standard deviation.
Okay, is it 2 or 4?
2 squared is 4.
What am I going to put in for k? 2 or 4? 2, right? 2 standard deviations above, 2 below. If I put in a 2, this ends up being 75%. Is that my answer? 75% are between 12 and 72.
At least.
At least. That is incredibly important. Chebchev's rule is the one that says at least. So at least 75% of the speeds were between 12 and 72 miles an hour.
Wouldn't you like have to do like put in a fraction because it says proportion, or can you still do percent?
Good point. Good point. Yeah, it says proportion, and you guys know that I don't like a percent when I ask for a proportion. So instead of 75%, we're going to write 0.75. Thank you.
So should you erase the 100 out in front? Because that would make it.
No, because that's really the rule. So maybe I would do something like this, 75%, and then convert it back to a proportion. Okay, so that was A. B, what proportion of vehicle speeds exceeded 72 miles an hour? Any ideas?
Like 125.
You just think 0.125?
At most 0.25.
Which one is it? 0.125 or 0.25? Or something else?
125.
Something else. 'Cause you're not saying it's right.
Sometimes I want you all to think about it. Do we know anything at all about the shape of the distribution?
No.
No. Is it possible that there's nothing below 12 miles an hour? Is it possible that the rest of the data is between 12? Or below 12, I mean? Yeah, we don't know. So it's anywhere between 0 and 25%. So the way that we word that is at most, and then not percent, of course, a proportion, at most 0.25. So at most, 25% of the speeds were above 72 miles an hour. So anywhere between really 0 and 25%. Questions? Comments? Okay. Next one. Upon closer inspection, a histogram revealed that vehicle speed at impact could be described by a normal curve. What are they telling us? Use the empirical rule. Inside what interval do approximately 95% of observations lie?
12 and 72.
Yeah. 95% is 2 standard deviations, which we already calculated up here. So we would say between 12 and 72 miles per hour. And remember, what's really important with the empirical rule is it's about 95% fall between 12 and 72. Roughly what proportion of vehicle speeds exceeded 27 miles an hour? 27.
Well,
No, I think I meant that one.
that's like minus 1 standard deviation.
Yeah, so it's 1 standard deviation away. You calculate a z-score. So it's 27 minus our mean of 42 divided by a standard deviation of 15. So we get a z-score of -1. So this is what we're looking at. We have a normal curve. Okay, these numbers are z-scores. So this is the mean. This is 1 standard deviation above the mean, 2 above the mean, etc. Our mean is 42. 1 standard deviation below is 27. So it's asking us what proportion or what percent? What proportion exceed 27? So it's looking for all of that. How are we going to find that?
To look at that section that we don't want to look at.
Yeah, I would probably try to figure out what that is. How do we figure out what that is?
Would we take a 2.5 and 13.5, add them and subtract that number from 100?
2.5 and 13.5?
Yeah, for the percentiles.
Where'd you get 13.5 from?
So that
95 minus 68 divided by
95 minus 68 divided by 2. So this part is 13.5, you're saying.
Yeah.
This is 13.5.
2. Yeah.
Or this,
All
no,
16,
this.
I think.
Between -1 and -2.
Okay, so this is 13.5, and then that's 2.5, and then you added them together,
Yeah.
and then subtract from 100? That does work, yes. I don't think of it that way, because that's more complicated than my way of thinking. Like, that just confuses me, but that is correct, yes.
Would
Another
it
way?
be easier to just say like everything above 0 is like accounts for 50%, and then do like half of the that.
So this is what Brooke is saying. Above 0 is 50%. Between -1 and 1 is 68. So if I divide that in half, that makes this 34%. So 34 and 50 will give us 84%. So about 84% of speeds exceed 27. Well, I guess as a proportion though, because I asked for a proportion. So about 0.84. What I would have done is I would have figured out this tail. Way to figure that out is to take 100 and subtract 68. You get 32. That means 32% is outside of -1 and 1. If you divide that in half, this tail ends up being 16%. So you do 100 subtract 16 will give you the same 84. Questions?
I just have a general question on K values.
Okay.
So if you have like a mean, let's say it's like 10, and then you were 1 standard deviation below it, so you were trying to find something that find the times between 5 minutes and then 20. So you're saying,
Are you using the empirical rule or Chebyshev rule?
The empirical rule.
Okay, so it's a normal distribution.
Yeah.
And you said
Chebyshev rule.
Chebyshev's rule. Oh, okay.
Sorry.
Okay, so this is what Kate just said. She said we have a mean of 10, and we're looking for the data when your standard deviation was 5,
Yeah.
and we're looking for the percent of data between 5 and 20. And it's not normal. She's saying, how do we handle this? Because 5 is 1 standard deviation below, 20 is 3 standard deviations above. Right? Is that what you're asking?
Yeah.
I go with the more conservative estimate. So the more conservative estimate would be to use 1.
Okay.
So if you use 1, you're going to get a number that's too small, but 3, then your estimate will be too big. So I would always go with the lower one. And the nice thing about Chebyshev's rule, which you're going to have to do in the homework, is k does not have to be a whole number. So you can take k to be 1.5 or 1.7 or something. Do you guys have in you one more question, which will help you on your homework? I promise. It's not on here though, so you're going to have to, I don't know, write this somewhere. Or at least listen. If you just want to listen, that's fine. Okay. The paper answer changing on multiple choice tests revealed that for a group of 162 college students, the average number of responses changed from the correct answer to an incorrect answer on a test containing 80 multiple choice questions was 1.4. The corresponding standard deviation was 1.5. Based on this mean and standard deviation, what can you tell about the shape of the distribution of the variable number of answers changed from right to wrong? What can you say about the number of students who changed at least 6 answers from correct to incorrect? Okay. So here's what they're telling us. You have a bunch of college students that took an 80 question test, multiple choice test. And they looked at how many times did you change your answer and you ended up going from correct to incorrect. And so it found that the average, the mean, was 1.4. And the standard deviation was 1.5. And they want to know, what does that show us about the shape? What's the only shape that we know how to do anything with really right now? Normal, right? That's all that we've done this section. We've done normal and then we've done everything else. So really they're asking you, is this distribution normal? What's your inclination? What do you feel like we should probably do? What have we been doing with normal distributions?
Drawing them.
Draw. Okay, so let's draw it. Okay, so our mean is 1.4. Our standard deviation is 1.5. So this becomes 2.9, 3.4, 4.9. This is negative 0.1, negative 0.16, negative 0.31.
4.4.
Which one?
4.4, 5.9.
What? Oh, this is,
1.5.
No, those are
On the
correct.
left, on the left
On
side,
the
you know, it's
1.6.
negative 1.6.
oh yeah. Thank you.
There should be 4.4. On the
4
right.
point-
On the right. So that's
What is this?
negative 2.1.
Negative 3.1.
Okay, so that was right.
Yes.
Oh my gosh.
2.9 plus 1.5 is 4.4.
Okay, is this a little better?
Something Chinese things.
Here, give me a break, okay? Okay. So, what do we think about this? Did this help us at all?
Yeah.
Part of this shouldn't make sense.
Yeah.
Does any of this make sense at all?
No.
No, you can't have a negative number of answers changed. Okay, so if this data set were normal, what percent of the data should fall in the part that I just highlighted? If this were a normal distribution,
16%.
okay, so between here and here is 68%. So if you do 100 minus 68, you get 32. Divide it in half, so this is 16%. If this were a normal distribution, 16% of the data would fall negative 0.1 and below in terms of number of questions that were changed. That doesn't make sense. So what we can say is this distribution is not normal. There's no way it can be. And we would say in a normal distribution, about 16% of the data would fall more than one standard deviation below the mean. We would say that's not possible here because that would indicate a negative number of responses changed. So this distribution cannot be normal.
Could you go ahead and say that it would be skewed left or negatively skewed, or could it be like a different, it could be like bimodal or something, right?
It could be bimodal or uniform
So you
or,
could just say it's not normal.
yeah, all we can say is we know it's not normal. questions.